Okay, good morning, everybody. Thank you so much for joining us today. We really appreciate it. We're going to get started here. We're going to be talking about advanced indoor grow room controls today. And we want to make sure that you know who you're talking to.
Yeah, so to introduce you to ourselves, I'm going to introduce Kelly. Kelly is our Sales Director in Controlled Environment Agriculture. She's got herself a Bachelor of Arts in Communications from Humboldt State. She's been over 18 years in the hydroponics industry, serving everyone from small home gardeners all the way up to large multi-acre farms. She served on a couple of boards of directors, especially the Hydroponic Merchants Association, and she's done lots of on-site training and installations throughout the world, the US, Canada, New Zealand, and down in Australia.
Then a little bit about my co-presenter, Kevin Blackmore, who is the product manager for IntelliGrow. He is a Master of Engineering Studies from Auckland University of Technology. He's got 19 years with IntelliGrow, of course, beating me by 1. He's been the design engineer, the R&D manager, and the product manager. And he was the lead designer of our very popular IntelliDose and IntelliClimate line, as well as our multi-grow product lines. So who is IntelliGrow? So established in 1994, IntelliGrow is committed to creating original ideas for agriculture and making them a reality. With a global headquarters in Auckland, New Zealand, an office in the US, and growers and resellers in over 40 countries, IntelliGrow provides affordable, accessible, and easy-to-use innovation 24/7 anywhere in the world.
Yeah, and we try to leverage the power of technology, data science, and the plant biology, using a team of software designers, engineers, crop science experts, and we're trying to push the innovation boundaries to gain the best results for the growers.
So let's get to it. Advanced grow room controls. So we're going to be covering a bunch of different topics today. We're going to be talking about project planning and retrofitting of buildings, things to consider when you're doing installation, risk management, nutrient feed schedules. We'll be discussing irrigation options. We'll get into a bit deeper into CO2 than we've done in the past. We're also going to be discussing lights, odor control of indoor grow rooms, and we'll be touching on energy efficiency.
So the first question you'll ask is why is it important to automate? When you've got automation, an automation system is usually programmable, and therefore you can customize it to what you need, giving you things like time schedules, set points, and alarms if anything goes wrong. Once you've got that automation in there, you're going to have decreased labor costs, you should get increased crop yields, and it'll help you avoid those costly mistakes that happen usually through human error. You forget to water a crop, or you accidentally overdose a tank, that sort of thing, and it'll mitigate a lot of those risks that are associated with human operation. By automating it, you'll be able to mitigate a lot of those.
Yeah, and with automation, you can set up remote access with alerts and alarms. So it's really important that you have that to help cut down on your risk. So the minute that something is to go wrong, you know immediately. So project planning, this is where we're just going to start. We're just going to touch on this a bit. I mean, we could talk about this for a very long time, but some of the things that you need to think about in the beginning, if you're building a new grow room, you've got a couple different options. We're either going to be talking kind of smaller grow rooms where maybe you're retrofitting a garage or a basement or a spare bedroom and doing just a single grow room. Or you could be discussing a huge warehouse indoor growing facility. So there's obviously a lot of different considerations depending on how large you're going to go. Building brand new, especially if you're doing a warehouse or whatnot, or any type of building, is always going to be desirable because it's going to be the ideal design. You can design ceiling heights, you can design, everything that you want in that grow room to be perfect, but it's more expensive, of course. Now, retrofitting, on the other hand, can be less expensive because you're taking a structure that's already been built. You've got, the land's already been graded, the structure's already been built, and you're just going in and making it work. But sometimes with retrofitting, the problem is that you have design flaws for indoor growing that you can't change just because of the way that the building has been structured from the beginning. Another big consideration when you're designing what type of rooms you're going to develop or design, is if you're going to be an open or a closed grow room, or if you're going to be a hybrid. So an open room, when we discuss this, is an open room is having intake and exhaust fans that use outside air to pull into the room, to cool it down, and then to purge out, humid air, stale air. So you're bringing outside air in and exhausting the inside air out. A closed room doesn't bring any outside air in. So a closed room is controlled purely by dehumidifiers and air conditioners. to make sure that the temperature and the humidity in the room are perfect. And then a hybrid would be a room where the air conditioner and the dehumidifier are the number one ways that we control the environment, but we do have the ability to exhaust. So if we wanted to exhaust at night for CO2 management, or we needed to have an exhaust as an alarm for building codes, you can have a hybrid system. So open or closed rooms, or if you're going to do hybrid, those are some decisions to make up front.
Another thing to consider when you're planning your new build or retrofit is what sort of water requirements you're going to need. When you're irrigating plants using, say, a deep NFT or a deep water culture type system, there's going to be a lot of water that's going to be suspended around the facility, and you need to take into consider that how much weight that is on your load bearing walls or on the ground, and also how big the storage tank needs to be. If you've got a large facility, you're going to need a large volume of water to keep those plants well fed and nourished. And that's something that a lot of people don't consider at the start, and they find that they need more water than they expected, and so they end up having to buy the land next door or do some crazy split tank type systems. Another consideration is the wastewater treatment. A lot of districts, councils, counties are restricting the amount of nutrient-rich effluent that you can put out into your stormwater drains. And so if you are doing a system where you're watering into a substrate, you're going to have a runoff that you might need to collect and treat and feed back into the system. There are benefits to that, in that you're able to reduce the amount of nutrients that you're purchasing, and you're able to recycle that water and stop polluting the environment. But that's something you'll definitely want to check with your council or your local board, just to make sure that you're not going to be breaking any laws.
You also want to consider your harvest flow. So when you're ready to harvest your plants, what's the least labor intensive way to move these plants outside of the room and out to the market? So, are you harvesting at the back of the room? Are you near a door? Do you have bay doors that open up so that you can move an FT channel in and out? How are you going to clean your equipment? Things like that are all really important to take into account at the beginning. So retrofitting, though a lot of new indoor gardens are retrofitting of current buildings, some of the things that you need to take into consideration. The big one is ceiling height. So many buildings that were built for humans, let's say office places and whatnot, they've got 8 to 10 foot ceilings. Well, if you're going to grow a plant that's going to get to be 5 or 6 feet tall, that ceiling's not going to be high enough. So you need to make sure that you take into account the crop that you're growing and how large it's going to get. Lettuce and leafy greens can have much lower ceilings than a vining tomato crop, for example. In an indoor growing environment, you want to have a lot of air around the plants, and you want to be able to manage that humidity and temperature. In really tight growing areas, that gets to be much more difficult, which leaves the plant susceptible to molds and pests.
Yeah, and another thing to consider when you're retrofitting is your row width, because in a lot of cases you won't have control over where the walls have to stay. You want to try and make sure that your row width is wide enough that you can fit all your equipment down between the rows, but not so wide that you give up really valuable growing space. So consider what type of equipment you're going to use, what sort of trolleys, how you're going to get the equipment in and out of the place, and make sure that your row widths are optimal. One of the things that is becoming more popular nowadays is a rolling bench system. So they're able to move the bench a few feet to the one way or the other, and then you're able to have a row that moves, and you don't give up any floor space for the plants. Another consideration is are there existing rooms in the building that you're retrofitting into, and which walls are the load-bearing walls, because those are the walls you won't be able to take down, you won't be able to move, and you're going to have to work around them. So check out which walls are the load-bearing walls, which rooms can and can't be changed, and also look at the weight, what sort of loads those bearing walls can take, because we can be, in a lot of cases, putting several tons of water onto the floor, onto the load for the building, and that can quite easily exceed the building permits for that particular structure.
Yeah, and what I've been seeing is if you find an old warehouse and We've had some people, retrofitting, let's just say like a lumber mill, which, the ceiling heights could be 60, 70, 80 feet tall. They're huge warehouses. They're actually just building rooms inside of the warehouse. So they've got their power supplies. Excuse me. They've got, the foundation has already been laid, that, so they can actually build the perfect room inside of a warehouse. So that's another option. As I just mentioned, power supplies. So your power requirements are really important. You need to make sure that you have the proper amount of power at the grow site running anywhere, let's just say, 3, 4, 500 grow lights. It requires a lot more power than what a normal office building would require. So it's really important that you bring the power company out to do a evaluation of the power system that you have and to plan for any type of power upgrade that you're going to need to do to be able to have an indoor growing facility. The other thing to keep in mind is the clean green. And as I mentioned with lumber mills, we have growers who've taken over, machine shops. And it's important that you get your environmental agencies out there to figure out what you've got going around in the thing. What do you have to do? Has the concrete been tainted? Do you need to, has there been any type of waste outside of the building that you'll need to take care of? Just making sure that you've got a clean green facility. And then, once again, harvest flow.
Yeah, so for harvest flow, you just want to take into consideration where the plant's going to be coming in, which way they're going to go out. Generally, the less you touch the plants, the better. And so in a lot of cases, you want to sort of feed them into one end of the building and then have them come out the other end of the building with nobody touching them in between, except for maintenance and monitoring of the plants. And with a retrofitting, I mean, just to touch on the pros and cons on that again, one of the pros of a retrofitting a building is it's going to be less expensive. You're going to have an existing structure. The land's already going to be, graded, as Kelly said. You'll have the concrete's already laid, and so a lot of that foundational work is not going to be required. That's usually a relatively expensive operation. And there could already be permits in place for the type of operation you're doing. And so look into that, see if anybody's already got permits, and that will save you a lot of time and a lot of effort. Of course, one of the cons, as we said, is it's going to be a lot less flexible than building your own facility. You have to work around existing load-bearing walls or existing driveways, waterworks. There's a lot less flexibility about how you can plan and build your operation, but it is a definite retrofitting is something that a lot of people are doing in a lot of warehouses and building growing environments nowadays.
So when you are, considering doing a new installation of an indoor grow room, the first thing I always want to tell everybody is plan for growth, plan for success. Know that you're going to want to expand your growing operation down the road. So, if you have 4 rooms and you just started in 1 room, make sure that what you're planning for, though, is to be able to expand into the other 3 rooms, because you don't want to purchase items for 1 room that won't be able to grow with you. It's really important. It's a time saver. It'll get you just a better system for the long term.
Another thing to consider is to make sure that you're planning for flexible control options. So market demands might change which type of crop is what you're going to try and grow in your facility in 2 or 3 years' time. And so if you need to make sure you've got a control system that's flexible enough to allow you to adjust how you're doing your dosing, adjust how you're doing your irrigation, maybe add some extra dehumidification or HVAC control, something that's flexible and can expand with you. And another consideration, this is especially important when you're retrofitting into an existing building, is the ability to install the equipment where it's most convenient. So with a lot of systems, when you put it up on the wall, you have to get all of the power lines, all the communications cables, they all have to come into that one central location, and that will quite often require you to rip the existing cable out and fit new cable in. So when you're trying to find a control solution for your new retrofit installation, or even a new build, having the ability to put your override switches where you need them, your sensors where you need them, with a simple communications chain is really quite important and quite valuable.
And it's really important to make sure that you can add on control. A lot of times you'll see, where a grower will say, I may not want to monitor the moisture in my media today, but I may want to, in 3 months. You want to make sure that you can add that on and that the equipment that you have can be added onto and that you don't have to actually scrap old equipment to add new equipment to the system. So just plan for that to be changing.
Yeah, so we've talked a little bit about planning, retrofitting, getting building. Now we're going to start talking a little bit more in detail about some more of the advanced indoor automation topics we mentioned earlier.
And before I move into the next slide, guys, hey, if you have any questions for us, please go ahead and put them in the GoToMeeting panel. And then at the end of the webinar, we'll be answering all of your questions. So please feel free to put those out. So one of the first aspects of dealing with an automation system for indoor growing is how are we going to manage our nutrients and our pH levels in the water that we're feeding our plants? And this is important no matter what media you grow in, whether you grow in soil or coco coir or rock wool or hydroton, whatever it is that you grow in, it's important that you manage your nutrients. So you always want to be monitoring the EC and the pH of the water that you're feeding your plants. And then you need to be able to have a control system where you tell it what set points you want. So let's say a 1.2 EC with a 5.8 pH. And you want the system to be able to manage that for you so that every single time that your plants feed, they're getting the exact proper nutrients that they require for that growth stage. In a lot of hydroponic farming, and even in soil farming, you can use supplements for different plant types to be able to kind of steer the plant to have different growing reactions for different growth stages. So plants in vegetative growth or plants in flowering growth have different nutrient requirements, and the supplements can help that along. So one of the most confusing things for new growers or even long-term growers is trying to figure out their nutrient recipes. So trying to figure out how you take these feed charts that you get from your nutrient manufacturers and turn them into something that an automated system can utilize. Because by hand, you're just hand measuring those out. But if you want an automated system, you need to be able to tell it how to do the proper recipe for you. So a quick example here. If you had 10 mils per gallon of A and B nutrients were recommended, with 5 mils per gallon of supplement 1 and 3 mils per gallon of supplement 2. Your percentages to keep your ratio right would be 100%, 100%, 50%, and 30%. So that's 100% of A and B, 50% of supplement 1, and 30% of supplement 2. Now, all automated systems will have a dose time, and there's many different ways that you can dose. You can dose via injection lines, solenoid valves, peristaltic pumps, but it's how long does that valve come on? How long does that pump come on? So for this example, with a 10-second dose time, the nutrient A would dose for 10 seconds, nutrient B would dose for 10 seconds, supplement 1 would dose for 5 seconds, and supplement 2 would dose for 3 seconds. This means that every single time you're dosing your nutrients, because the water has you've had fresh water top off, the plants have transpired, evaporation has occurred, we've brought that EC down. Every time that we need to raise the EC to hit our set point, we're going to make sure that we get the exact proper ratio so those plants are getting exactly what they need for their growth stage. Now, with a scheduling feature that's offered on our IntelliGrow software, you can actually go through and put this entire feed schedule in from day 1 of growth to the day of harvest. So you can go through and put all of your ratios in. As you can see on this slide, day 1, we may have 100% of, let's just say, one of our cocoa mixes. We've got 45% of, parts 2 and 3, and then another 100% of part 4, and we have a nutrient requirement of 1.0. But on day 8, we have a different ratio that we're using, and we're raising our EC set point. And we can do this so that the unit will know that as soon as the next schedule comes up, we will actually alter the amount of nutrients that are being used, alter the set points. So the whole schedule can be done for you. It just makes it really convenient if you want to have your whole schedule done. And of course, you can always go in and make changes as you see how the plants are developing. But if this looks a little overwhelming and a bit confusing, please don't hesitate to give us a call and reach out, because we're more than happy to help you with this.
So the next aspect of automating your system is automating the watering aspect of it. So some systems like NFT, nutrient film technique, and deep water culture systems, they're watered 24/7. So irrigation control is not necessary. You essentially you're feeding them that scheduled nutrient 24/7, so you don't turn the pump on or off. But when you're growing in a substrate like a cocoa peat coir or a rock wool substrate, you're going to top feed with drippers or injectors, and you want to try and schedule that and have an automated system that allows you to irrigate it at different times of the day depending on what growth stage you're in. And so there are multiple types of triggers that you might use for your irrigation system. Because we're talking about an indoor operation, we've got total control of the lighting, total control of the environment. So we take out a lot of the more difficult features like measuring the solar radiation. So we can, in a lot of cases, we can actually just run the irrigation at a particular time of the day. So perhaps you might irrigate at 10 and irrigate again at 2. Or if you know how intense your lights are, you might set it up periodically so it irrigates every 20 minutes on the dot, because you know that that's how fast the plants are going to be pulling that nutrient and the water out. But a better method is to actually monitor what's happening in the root zone using something like a moisture sensor in the root zone. So you've got a really good indication of what's happening in the root ball of the plant. So a system with a healthy root zone means you're going to have more healthy plants. And what you can do with the root zone monitoring is you can set an irrigation system so that it starts wetting up the substrates in the morning, and then it maintains the moisture level at the root zone at a particular level throughout the day. So when it gets down to, say, 40% moisture, so it's getting a little bit dry, then you can have the irrigation system trigger an irrigation, feed it that pre-dosed nutrient and water, and irrigate it until it gets up to, say, 50%, so that the plants are not getting over wet and they're not getting over dry, and they're just kept in that nice perfect zone.
Yeah, and there's, depending on what you're growing, there's different varietals, and different varietals will require different amounts of water at different growth stages. So being able to monitor the exact moisture level at the root zone is really important to making sure that you can actually steer those plants to grow at the rate that you want them to. So to push a plant into a heavier flower set, you may be able to dry it down a bit, put it through a tiny bit of stress, and then water it. So there's a lot of things that you can do with that information. If you've got the information and you've got the data, you can actually, adjust the way that you water your plants to get them to perform exactly like you want. So CO2. Why is CO2 important? If you've looked into any type of indoor gardening at all, or if you are an indoor gardener, you know that CO2 is very important to your plants. CO2 is sometimes looked at as a little extra, only for really big facilities. It's not even worth it for small grow rooms, and that is not the case at all. So plants need sugar to grow, metabolize, and that's what we want them to do. We want them to grow. And they use CO2, light, energy, and water to produce these sugars. So you have to have CO2 available during photosynthesis. So whenever the plants are under light, they need to have CO2 available to them. Now, the average CO2 is somewhere between 350 and 400 parts per million, kind of depending on where you are. It's usually a little higher in the cities, lower in the mountains. But the plants can function well at that. Obviously, outside the plants are doing fine. But when that CO2 gets down to close to about 200 parts per million, the plants will actually stop growing. So if in a grow room, depending on the size of the plants, like how big they are, lettuce and leafy greens will go through CO2 slower than tomatoes or, peppers, big, large vine crops. But large plants will go through CO2 very quickly. And in a grow room that had a lot of tomatoes in it, for example, you could go down to 200 parts per million within an hour. And so it's important that we're always keeping CO2 in the grow room. Now, if you've got an open room, like we discussed earlier, where we're bringing air in from outside and we're exhausting it, you can bring air in that will replace the CO2 that the plants have utilized. That CO2 is will still be around the 350 to 400 mark, but it will give enough CO2 for the plants to at least continue to grow. With closed rooms, it's really important that you have to add CO2 because they will run out of CO2 very quickly, and then they will have a stalled growth rate. So this chart kind of shows you a bit of excuse me, where ideal CO2 is. So ideal CO2, when you try and get to like your 200% normal growth rate, is going to be around the 1,000 to about 1,400, 1,500 mark. Once you get past 1,600 parts per million, it's really just a bit of an overkill. And at that point, you're just wasting CO2 and the plants can't utilize it. So though you can just do an air exchange and bring in that 350 to 400 parts per million CO2, the plants are actually going to have much more increased growth rate if you can get that CO2 up over about 800, 900 parts per million.
Yeah, and when you're looking at this, you can really see the benefits of having an indoor operation compared to just growing outdoors or in a leaky old greenhouse. By controlling that CO2, you're able to get double the growth rate as you would be in natural outdoor conditions, and that's a real benefit when you're growing indoor under lights, and it's something that increases your return on investment and will give you a much larger yield when compared to outdoor growing.
Yeah, so exactly. And it is one of the most, it's what you can control the most. So what happens when you increase CO2? So scientists refer to this as atmospheric fertilization. Sorry, let me say that again. Atmospheric fertilization. It's a bit of a mouthful, but it's actually fertilizing the air so that the plants can grow better. So the pro is that you're going to get way more rapid growth when you add CO2. You can have up to a 30% increase in your yields based on just utilizing CO2. So when you are adding CO2, the plants are more likely to add stems and branches faster. As stems and branches grow faster, you're also going to kick in flower production. So when you're growing a tomato, for example, you want the flowers to set as soon as you can because a flower turns into a tomato. So if we can grow really thick stems and branches on that tomato plant, get those flowers to set earlier, and get our tomatoes to be growing faster, and we get a 30% increase in yield, that's a huge pro of using CO2. You get that control. One of the cons, there's just a few little cons of using CO2. There is an increase in costs. Of course, you have to put a CO2 system in place. We'll talk about that in just a second. But when a plant is actually functioning at that super enhanced level, they're going through more water, they're going through more nutrients, and they're using a little bit more of your energy. Now, these costs are minimal in comparison to a 30 to even up to a 50% increase in your yields, but that is a bit of a con. And then the only other thing that you really have to keep track of when you're doing CO2 is that if you get above about 4,000 parts per million, that can be really dangerous to humans because now all of a sudden we have more CO2 than we have oxygen. And obviously we need oxygen. So you'll find that a lot of building inspectors and a lot of the local city and county permits and whatnot when you're doing an indoor growing operation will require that you have an exhaust fan on your indoor grow room if you are injecting CO2 inside as a safety feature. If the CO2 gets too high, you can exhaust it out. So that's another example of using that hybrid grow room where it's a closed room, but you do still have an exhaust fan for situations like this. There's also CO2 extraction at night is important. So during the day, the plants are utilizing the CO2 to help them grow, and they are giving off oxygen. At night, they release more CO2 than they do oxygen. So towards the end of a night cycle, when all the lights are off, the plants are obviously not using CO2. They're not photosynthesizing. So the CO2 can get very high, 2,500 to 3,000 parts per million with really large plants. So it's really just dependent on the size of plant that you're growing, but you may need to purge that air out and get that CO2 out of there. Now, in a large greenhouse, that can be dangerous because it's a lot of CO2 that you need to get out. There's not enough oxygen in the room. So it's important that you do an air exchange once or twice throughout the night. In a smaller growing room where they're building up that CO2, it may only get to maybe 13 or 1400 parts per million throughout the night, which actually is great because when the lights turn on and the plants are photosynthesizing, the CO2 is already in the room. So a lot of these settings, really, the size of a room can change everything. A 10-foot by 10-foot room or 1,000, by 1,000-foot warehouse, very different requirements when it comes to things like CO2. And there's different ways to increase your CO2. So the two most popular are going to be propane burners. So this is once again for, dependent on the size of the room that you're in. So for larger grow rooms and big facilities, propane burners are the ideal situation. So you have a local gas company that comes and fills a really large propane tank outside of your facility, and you have burners in each of the rooms. Whenever your automated system notices that your CO2 is too low, it triggers the burner to come on, which burns propane, creating CO2 for your grow room. Now, warm CO2, so when it's burned, it's hotter and it's less dense, so it tends to stay up higher in the room. So it's important that you have vertical airflow fans as well as horizontal airflow fans to push that CO2 down into the canopy of the plants so that the plants can utilize it. The other aspect is that propane burners, of course, will give off heat and they can create some humidity. Now, in a large growing facility with industrial sized dehumidifiers and air conditioning units, that's not a big deal. It can be managed really easily. But in a smaller facility, like let's just say like a 10 by 10, a statistic I read said that a burner can increase the temperature by about 5 degrees and increase the humidity by about 7%. So you can see how in a small growing environment, a propane burner could be really difficult to manage, whereas in a large warehouse, not so much. The other option is to just do natural CO2 injection from tanks. So as you see in the picture there, those are just tanks of CO2. And these are easily movable. They're, 10, 20, 30, 40 gallon tanks that you can pick up from your local gas company. You can just set it in your grow room and you can attach an injection valve to it that can be run off of a timer or an automated system that tells it when to turn on and off. Now, this type of CO2 is going to be cooler and it's more dense, so it actually tends to sink. So having fans lower to the ground that will push that CO2 up into the canopy of the plants is important. It's also, when people are putting these in, a lot of times they'll run the CO2 piping behind an oscillating fan so that the fan will actually just blow the CO2 all over the room. And this is great for small rooms because you can just get a 10 or a 20 gallon tank. It doesn't create any additional heat. It doesn't take up much room. But would be very difficult in a large facility to move these around and to get enough CO2.
Now, with when you're growing indoor, all the light that we're providing to the plant is going to be artificial, and we can divide the lighting typically used in most operations into sort of two categories. There are HID lights, which stands for high intensity discharge lights. They're available in two different varieties, metal halide and high pressure sodium. And then what's the newer, more modern category is LEDs, and we'll get to that one next. So in the HID lights, these are a more traditional light, and we find these being used in a lot of operations where you're growing a much larger plant, where the plants are going to be bigger, requiring a larger spread. And as I said, they're divided into two categories. So we've got the metal halide lights. They tend to be a slightly blue color. As you can see in the spectral chart on the right-hand side, there's a slightly more blue coming out of a metal halide light, and that sort of promotes a vegetative growth. That'll give you shorter, bushier plants, and you use this when you're trying to promote the vegetative growth, get the stems growing, get the plants growing a little bit more. And then what we find is a lot of people transfer the plants into another area growing under high pressure sodium. And high pressure sodium light is going to give you a slightly redder color, and this will promote a more of a flowering, more generative type growth on the plants. So what we tend to find in a lot of the operations is that they'll start off under the metal halide and then they'll transfer over to the high pressure sodiums to promote the flowering. There is a newer HID light that's coming out. It's a ceramic metal halide. That one has a lower energy footprint, and it's tends to have quite a high intensity, but there are some pitfalls to that. They don't recommend people working under them for more than 10 minutes or so. So you either have to have shielding, or you want to try and work on the plants during the dark hours rather than during the daylight hours. So some of the advantages to the HID lights is if you're in a cold environment, metal halide and HPS lights, they tend to operate very hot, so they generate a lot of heat while they're producing that light. And that can be beneficial in a lot of cases, but it can also be a con for the system, because you'll have to increase the size of your HVAC system to provide a little bit more cooling. You may need to put a fogging unit in to get the humidity up, because they'll be drying it out, and that's one of the side effects of using this type of light. The other type of light that people are using, this is becoming more popular moving forward, is LED lighting. So with LED lighting, you've got full control over the full spectrum of the light. So what the manufacturers are doing is they're creating little light emitting diodes The light emitting diodes are specifically designed to give you a certain spectral response, and by tuning those and picking which colors you put into your LED, you can have full control over the spectrum. And in some cases, you can actually adjust the output from the lights to give you a variable spectrum output. What we found in traditional operations is that the LEDs are used typically in vegetative growth. They tend to be used in the blue and the red and the far red type spectrums, but we're seeing a lot more adoption of LEDs in operations where they're growing a fruiting crop or a flowering crop. The benefits of using LEDs is that they require less power. They're going to be much more efficient. They'll have a longer life. I've seen reports that LEDs last up to 50,000 hours compared to, say, 3,000 hours for a HPS, and they run cooler. The running cooler part means that you'll be able to reduce the size of your HVAC system, reduce the amount of cooling, but a side effect of that is that you might actually need to add heating to your operation if you're in a colder climate. And with the control over that spectrum output, that gives the possibility of us being able to adjust the spectrum throughout the growth cycle. This is something that a lot of people are doing a lot of research in, a lot of scientists are looking into this now, because with these LEDs, we can change the spectrum that the plants are exposed to from day 1 to day 8 to day 20. And just like with the recipes in the nutrient side, we might be able to change the light spectrum output and steer the plants toward a more generative growth or a vegetative growth, and allow us to get benefits, better yields, slightly faster growth, and there are other benefits.
Yeah, and we've also have seen that there's quite a few growers are using LEDs as supplements to high pressure sodium bulbs. So they've got the high pressure sodium bulb, which is giving off that nice red orange color that the plants want. They've got the heat from the high pressure sodium bulbs, but they're also using LEDs either alongside of them or on side of the walls as a supplemental light. So there's a lot of places for LEDs in the future of indoor gardening. Excuse me. So odor control, something that we always need to think about when we're growing indoors. So depending on what you're growing indoors, and if you're doing exhaust, you could have to worry a bit about the odor control. So whenever you're doing an air exchange, which is bringing fresh air in and pushing stale air out, you need to make sure, depending on where you're located, what you're growing, what your local requirements are, that you've possibly treated that air so that there is no odor on the outside of your growing environment. There's two real popular methods of odor control. The first is going to be ozone generators. So an ozone generator, it will convert oxygen to ozone, and then it exposes the ozone to UV light. And that UV light then will sterilize the air, and then when the air is pushed out, there's no smell to it. Ozone generators can be costly, and they can be a bit dangerous. So ozone generators used in the proper way are really effective, but you can't put an ozone generator, I wouldn't say can't, but I wouldn't put an ozone generator in with the plants itself, because it actually takes the oxygen away and turns it into ozone. Ozone at too high of a level can be dangerous for plants and for humans. UV light also, for humans, you really can't look at UV light. So ozone generators, they're really effective. You have to make sure that you really know exactly what you're getting into and that you set it up properly so that it doesn't cause you or your plants any harm. The most popular way to control odor in a grow room is by using activated charcoal filters. So activated charcoal filters, they're full of activated charcoal, which is extremely porous. And as the air goes through the charcoal, it actually absorbs all of the odor that's in the air. So it's really important that you get kind of a very slow exhaust fan to pull the air through the filter so that the charcoal has enough time to be able to absorb that. There's usually a pre-filter on a charcoal filter that will collect all the dust and debris that could possibly be in the room before it goes into the charcoal. Really easy to clean and replace these. Charcoal filters work best when humidity levels are below 65 to 70%, and they're completely ineffective when the humidity gets above 85%. So it's very important that if you're using charcoal filters as your odor control, that you're also managing your humidity really closely. Then, one of the things too we want to talk about with automation of your indoor garden is energy efficiency, is how do we save energy? We know that indoor growing is very expensive. There's all the benefits like Kevin was talking about with being able to manage the CO2 and the fact that we have exacting control over our temperatures and our humidities and the way that we can steer plants to grow and we can change the way that they harvest. We can increase our yields. All of those things are amazing, but there's a lot of cost applied to that. So one of the first things that we want to talk about is that kind of hybrid system I've been bringing up this entire webinar, is managing your HVAC and your fans for the most efficient results. So when you've got a hybrid system, you can utilize the cool outside air to lower the temperature in your room. But if it's too warm outside and the temperature is lowering too slowly, you can switch over to air conditioning. This gives you the option that if it's cool in the mornings or cool in the evening, that you can just use the ambient temperature outside to actually cool your room down rather than immediately going to ACs. Now, this does open you up to bringing in pathogens from outside. So having filtration systems on your intake fans is going to be the most important thing if you're using outside air to cool the room down, but it is a way to be a bit more efficient.
Another thing to consider with the energy efficiency in mind is when a lot of growing operations, they want to get a diurnal temperature change in their grow room for their plants. So they might have a slightly higher temperature during the day or a lower temperature at night, or vice versa. And when you switch from one target to the next, from say 70 degrees down to 65, you might find that the system will slam on that cooling the cooler and expose the plants to thermal shock. So having an automated system that slowly ramps that temperature target from your day target to your night target allows you to get the maximum efficiency from your HVAC unit, and it stops exposing the plants from that thermal shock. Something else that you might want to do is to collect stats regarding your indoor gardening energy costs. So keeping track of the amount of time your lights are on, the air conditioning's on, when your dehumidifiers are running, and see if there's a way to save that energy. You might be able to run your lights off during off-peak hours, so have them run during the night and come in during the day and maintain the plants during their sleep time, and that can save you a significant amount. Another thing that we haven't really talked about in here is being able to run the lights for longer than is a natural day length. So in a lot of cases, you might be able to run the lights for 18 to 20 hours, depending on your plant, for a lettuce or what have you. And that way you can sort of increase the yield and make your growing operation much more efficient.
So to wrap it up, we talked about accurate nutrient recipes. When you're looking at an automation system, this is really important. You need to make sure that if you're going to be using supplements, that you're getting the type of injector, pump, valve that will allow you to be as accurate as necessary. So some of the larger injection systems that don't have the really tiny accuracy that you need for some of the supplements that you use at different growing stages. So make sure that when you're looking at the systems that you talk to the people about, how accurate can you get, like just exactly how can I do my recipes through your system.
Something else we talked about was making sure that we give the plants exactly the right amount of irrigation. And that involved sort of measuring the root ball of the plants with your moisture sensors, knowing what the EC is, what the temperature is of that root zone. And when you've got a healthy root zone, you'll end up with more healthy plants and better yields.
And then we talked a lot about CO2, of course. Well, I say. And yeah, there's CO2 it's really interesting. And I recommend that everybody reads a little bit about CO2 and how it works for the plants, because the positive result you get from adding CO2 to your indoor growing environment is, I mean, it doesn't really matter that it costs a bit more, or that you have to manage one more piece of equipment, because the results are just so much higher. And really experimenting with a level of CO2 in the plants that you're growing in different growth stages is going to be really important to a successful indoor growing operation.
And then lighting. Because we're growing indoors, we're controlling all of the light that the plants are getting. And so picking the right type of light for your crop is really important. So for an operation where you might have a larger plant, where you need a larger spread or more heat coming from your light, some of those high pressure sodium or metal halide lights might be better. And for a operation where you might be growing a leafy green or a lettuce or something like that, growing under LEDs could be more beneficial because you're able to reduce the distance from the LED to the plant, and you can reduce the amount of heat that is created and whatnot.
And then we just touched on odor control. So keeping in mind that there's a couple different ways to manage the odor of an indoor growing environment, with activated charcoal being the most popular. So that's our webinar. Please make sure that you add any questions that you've got. We're going to be back on April 18th. And keep your eye out for topics and times and things on that. And, go ahead and sign up. If you would like a call from one of us, please go to offer.autogrow.com and fill out the contact form. And one of us will go ahead and give you a call right away. We love to hear about your projects. It's one of my favorite things is to hear about how innovative everybody's going with their indoor growing operations. So please, feel free to reach out to us. We're more than happy to just answer questions, to issue quotes, to help you with your project design. You just let us know what you need.
Yeah, we're on Facebook, we're on Twitter, LinkedIn. So feel free to tweet, message us, whatever, to get a hold of us, and we can help you with your requirements.
Yeah, so let's go to the questions. So let's see here. Are there at-home methods for adding CO2 to the grow room? There are a couple. It's kind of an interesting thing. For small grow rooms, there may be a few things that you can kind of try. One would be dry ice, which is just frozen CO2. So you can put a block of dry ice into a styrofoam, container. Yes. Sorry, just kind of place that word, and poke a few holes in it. And then as the dry ice melts, it doesn't actually turn into a liquid. It just turns into a CO2 gas. And so that's a quick way to add CO2 to your room. There's also fermentation, which is very widely used in like the brewing process. So you can go to your local, wine and beer making shop, and they have little fermenters that use water, sugar, and yeast to create CO2. None of these, of course, are going to be as effective as actually putting CO2 into the room, but they're pretty inexpensive at-home methods for being able to do that. Let's see here. Ideal ceiling heights. So, well, it really depends on what you're growing on your ideal ceiling height. So if you've got leafy greens, one of the things that a lot of people like to do is they like to stack leafy greens in vertical farms. So, you can get, especially if you're using LEDs, which are run so cool, you can get those really close to the top of the canopy of the leafy greens. So you'll be able to stack those, and maybe you only need, 3 to 5 or 6 inches in between the lights and the plants. In larger plants, so if you're talking, big tomato vining crops or flowering plants, the higher the ceiling, the better. You want it, 20, 30 feet would be fantastic, so that you would have enough room for all the equipment, because you've got big lights and you've got dehumidifiers and you've got fans and everything that has to go above the plants. And you need enough room that you can actually move through, you move that air through, get it really circulating, so that we don't have any stagnant air or microclimates. Let's see. Will you guys help us first timers to set up our nutrient recipes?
Most definitely. That's one of the advantages of working with us. We've got more than a decade's experience setting up recipes for these types of operations, and I know Kelly's got personal experience using a wide range of different nutrient providers with their supplements and additives. So yeah, reach out to us, and we can definitely help you set up your recipes.
Yeah, we're here to help you with anything that you need. Any type of control questions that you have, you just let us know. And it looks like that's all the questions that we've got today. We're very happy that you joined us. Thank you for taking this time out of your busy schedule. We will be posting a link to this webinar on our YouTube page within the next week or two. So there's a way that we can kind of share it there. If you have any questions, please go ahead and reach out to us, autogrow.com.
Thanks for attending. Bye.